Chapter 8, Section 2, Part 1 discusses percentage composition, which is the percent by mass of each element in a compound. So for instance, here we have the water molecule. Even though there's actually 2 hydrogens and only 1 oxygen, by mass, still the majority of this molecule is actually oxygen. You can see in the pie chart here, it shows you that almost 89% of the molecule is going to be made up of oxygen, while only about 11% will be hydrogen. So to find percentage composition from a chemical formula, you're going to take the mass of the individual component and divide it by the mass of the entire compound, and then multiply 100 to get a percent. So ideally, at the end, you should be able to verify your answers to make sure that all the individual components percentages add up to approximately 100. It might be slightly different than that based on how you've rounded, but you should get very, very close to 100. Here's a sample problem. This one says to find the percent composition of a copper sulfide. And the first thing that we want to do then is to look at the periodic table and find out what the atomic masses are of each of our individual components. So we've got 2 coppers here, and on the periodic table, the copper's atomic mass is 63.55 grams per mole, and for sulfur, we've got 32.07 grams per mole. Now, since there are 2 coppers, we need to multiply its value by 2 so that we have all the copper together. Once we have that, then this would be the work that you would show me. You're going to divide each mass by the total mass of the compound and then multiply by 100. So this is the molar mass of the 2 coppers, and then the mass of the entire compound, the 2 coppers plus a sulfur, all added together, is 159.17 grams per mole. So we divide, multiply by 100, we get 79.85% copper, and then we're going to take the individual mass of the sulfur, divide it by the total for the compound, multiply by 100, and that will tell us that the sulfur is making up 20.15% of this compound. So when we add these 2 percentages together, we get 100%, and that's good because that's what we should get. Now make sure when you're doing these that you do all of the individual components in a separate calculation. You don't just do one of these parts and then subtract this percentage from 100. That way, in case you make a mistake on this first part, you still can get the other parts correct. Hydrates we have talked about before. Hydrates are ionic compounds that have water molecules attached to their crystal lattice structure. And so we'll also be using the similar formula for percentage composition to find out the percentage of water in a hydrate. So we're going to take, instead of the mass of an individual component, we're going to take the mass of the water molecules and divide it by the mass of our entire compound and then multiply by 100. So here's a sample of that. For this one, it says to determine the percentage water in sodium carbonate decahydrate. So we want to find out the molar mass of these waters, and we need to find out the molar mass of this entire compound. So if we add up 10 water molecules, we're going to get 180.2 grams per mole. And then if we add those 10 waters in addition to 2 sodiums, a carbon, and 3 oxygens, that'll give us 286.2 grams per mole. And again, those are just the atomic masses added together from the periodic table. Do our division, multiply by 100, and we get 62.96. So that's telling us that this hydrate is actually made up of 62.96% water. Now, when you see these problems in the textbook, sometimes they ask for the percentage water, and sometimes they ask for this percentage of the anhydrous salt. If that were the case, then you would put the mass of the sodium carbonate on the top and divide it by the total of the hydrate. So if they want the anhydrous part, that's the dry part at the beginning. If they want the water, then you would put the water molecule's molar mass on the top of the equation.